Thank you, Mr. Chairman, and thank you very much for allowing us this time and space to talk at this conference. I'm going to try and be short. So first of all, a quick, is working out? Okay. So a quick introduction to the Institute for Security Science and Technology. So I'm the Deputy Director of that institute, which is based at Imperial College in London. And essentially what we're trying to do at Imperial is to address an issue which we've seen as being a fairly major one over the years in addressing all sorts of security problems. And that's trying to bring together communities from government, where normally the requirements are held, industry, where normally the final products and solutions are delivered from, and academia, which is traditionally seen as the space where novel and bright ideas might emerge, which might one day solve some of the outstanding problems that we might have. So the Institute has really been set up to do that. Imperial College, as many of you know, is regarded as one of the top technical universities in the world. And so we have a great depth of technical experience from engineering, medical sciences, business and physical sciences. And the Institute is really there to try and draw from all of these disciplines to come to bring together expertise from these different areas to solve some of these problems, because we believe that some of the pressing problems for security, and certainly some of the problems that will emerge in smart cities, require a blend of these various disciplines. So personally, my background prior to going back into academia, I initially started off in physics, and I did a PhD in physics many years ago. And then I joined the government, where I worked on regulation and transport security. I was in the Department for Transport in Whitehall. So I worked in regulation setting, policy setting, technical standards, advising the Secretary of State on several national incidents that we had over the 5 years when I was there. And so I want to address really the mix of the different areas and disciplines that are required to address the implementation of technology for security problems. And we can use aviation potentially as a kind of good model for that, because I suppose it's one that most people really recognise. So when we're designing a security solution, what are the steps that are really needed to do that? And I've had a lot of discussion today, and I've seen a lot of discussion over the last couple of days as we've been here around separate products for separate parts of the puzzle. And in fact, what's I think very important to do is to try and understand in a very holistic way what the overall security requirement is for any particular asset or problem space that you're looking at. And that really requires an architecture that has many different technology components painted within it, the interconnections between those technology components mapped out, a deep understanding of the operators and the people and the humans in the loop, which I think is absolutely vital, who will be operating that infrastructure, an understanding of how these humans degrade over time in terms of their times on task, and exactly what that then means for the overall value of the security system that you've put out there. So it's all very well having an architecture that looks like it delivers a very high standard of security, but at what rate does that standard decay over time, and what can we do to mitigate those things so that we end up with a constant level of service from a given security roadmap. So really you're looking at requirements capture, and that's all that good sort of risk-based analysis stuff, and understanding what sort of policy spaces that you're working within, what the public appetite is, for example, for certain security measures. And then following that, a brainstorming around architectural design, so coming up with some ideas of architecture that might fit some of those requirements. And then there's an iterative step where you basically need to test that architecture somehow, maybe through modeling, maybe through other scientific and quantitative processes. That then takes you maybe back to your architecture where you do some improvements and you retest, and you probably go around this loop a few times. And it's only then that you come out with a down selection of maybe a security system which you think might be implementable. Then we start testing the components, then we start testing the components together in that architecture, and only then do we get to the stage of rollout and implementation. And even that rollout and implementation should be phased, because we can never test everything offline that we would experience in the real world once the technology actually hits the real environment. So just to conclude very quickly, that's kind of where we are at the moment. We're moving towards this idea of smart cities. What does that really mean? Well, it means embedded sensors in our environment, it means embedded technology in our environment, but it means a little bit more than that, right? It means a moment where human elements, physical elements, and cyber elements, or if you want information elements, will all be very tightly integrated with one another. So you've heard the phrase cyber physical systems or physical human systems. Well, we'll be dealing with a human physical cyber infrastructure that is delivering an environment for humans to live in. That will be what the urban environment is composed of. And so the security problems that we're going to have to deal with will need to address all of these three things together. So there shouldn't be these silos of cyber security, physical security, chem, bio, rad, nuclear, or explosives. In fact, all of those problems have some element of those three components that I've just outlined. And I think that's going to be a real challenge moving forward, understanding how to frame the policies that will actually deliver good security and will then actually lead to implementations of technology. So I'll leave it at that, and maybe we can explore some of that in the discussion if we have time.